So hello everyone, welcome to Cloudbusters. We're hosted by myself, Alex Hullah, and Mallory Beaudreau, and we're here to help try and unpack some of the challenges, the myths, the problems that we experience when adopting public cloud or adapting our organizations to work with these new cloud processes. And to that end, we want you to reach out and get in touch with your questions you want our help in answering.
Our first guest, we are so thrilled to welcome Erik Onnen, the Chief Product Officer of Mobilize.io. Erik, thank you so much for joining us and getting up early for this conversation.
Thank you both for having me. It's good to connect with you again.
We are so thrilled to have you on and talk about some of the developments that happened in 2020, right? Some of them have been building for a long time, but there were some really interesting things that happened last year, cloud-wise, right? Everything else aside. So something I'd like to start with is data sovereignty. And let me explain for you and for anyone listening, what I mean by that is, of course, we had Brexit at the end of 2020, where we had the official, the divorce was finalized, as it were. And right after that, what happened was Facebook took the UK users and put them on US terms instead of European terms. Now, in the meantime, you have GDPR, which is a data privacy requirement for the EU. And you have the recent development of a project called Gaia X, which it's not a cloud service provider. It rather is a project bringing together different data infrastructure that adheres to EU principles. So you've got a lot of different developments. Those are just some. There are quite a few others around data privacy and also keeping data sovereign within a region. This seemed to accelerate in 2020. And if you're a multinational, right, if you're an enterprise and you have employees in multiple countries and data privacy areas, customers in multiple data privacy areas, your cloud teams now have to consider not just the latency of data transfer between regions, not just kind of the basic security and performance considerations of the workload, but now you're asking them to consider, well, where do I need to place it from a data sovereignty standpoint, right? Like if you're doing a workload placement exercise, this becomes one extra thing for your engineering teams to think about before they actually spin something up.
Yeah, I would almost look at that as, I see sort of, if I put on my engineering hat, three different facets to that discussion. So number one is there's always some degree of CDN or edge computing to improve latency, right? So you may be a US entity, but you're gonna have a CDN that operates in a regional locality. And oftentimes at those CDNs, you break the trust chain in certain ways, right? So the data is unencrypted slightly for part of the transfer if you use somebody like a large scale CDN, because they control the certificate of authority and then they hand it off to your sort of transfer. But there is a moment in time where the chain of trust is broken, and does that have privacy implications over time? Right now it doesn't, we don't think about that, but it's kind of a fundamental part of how the internet works. But then there's also the IoT facet of it, which is emerging as well. So if you start to think about edge devices that are deployed in the EU and they capture some information about you as a user just passively, the fact that your device was in a coffee shop, that's not you interacting with a CDN per se, but that is data capture for you as a subject that happens in regional localities. And then there's kind of the processing hub. So in general, right now, you're not seeing data being captured about a subject in, say, Germany and processed in Germany every single time. Like, it's not bounded to nation states. It's always sent somewhere else for the most part. And that's kind of where I think the cloud discussion becomes really interesting, because in a cloud world, we can provision infrastructure to pretty much any locale, like maybe not a specific nation state right now, but we can at least get pretty close to where we want to do the data processing. And does that start to factor into not only the IoT facets of things, not only the CDN facets of things, but the data processing side of things? Because we have that as an option, and maybe that's a cleaner model for us to distribute the processing of data subjects out to the edges or closer to where the subject resides, closer to where the data is observed, things along those lines. There's also emerging information security standards that are starting to show up, like CSA star, which tends to be a little bit more European and ISO 27001 oriented. And that's more focused on just your information security in cloud as a service provider as a standard. It's still more emergent. I don't see it a ton, but I'm starting to be asked about it more and more when we're trying to engage with European businesses. And
the one thing I felt like people were talking about a lot last year was I think we've kind of got used to the idea that, okay, just running kind of on plain old infrastructure as a service isn't necessarily the most kind of efficient way if we want to kind of bin pack our services as tightly as possible. So you get into the whole kind of, do we do Kubernetes? Do we do serverless? And kind of, do you think we're going to get to the bottom of, what is the right answer there? Because I feel like people go back and forth on it a whole lot. And also, we've seen a lot of this kind of change in the model. So kind of what's after serverless? We're currently looking at serverless as the best thing, but what comes next?
Well, I think you'll see an increasing ubiquity of what we generally think of as serverless, right? I personally really despise the term serverless because there's always a computer there at the end of the day, right? So I really think containers as functions is probably closer to our end state. I think my personal experience, what I've heard from peers is that maintaining functions independently is a little bit harder as a code base. And you've seen motions from cloud providers to allow more modularity to that so that you get better reuse out of a code base. And I just think a containerized approach to that is generally easier if you don't have sort of a cold start problem. And I think the vendors will work around that over time.
Something I want to comment on, Alex, is your brain is always going to the next big thing. And something that I'm seeing with enterprises in Europe, at least, is they're not at the serverless part yet, right? Like they are still working their way through that journey. And so this is very much a look forward part of this conversation, right? Like what I'm seeing is maybe some dabbling with Spot, but the sort of, you can lose it within a couple of minutes, puts a lot of enterprises ill at ease. You see a lot of containerization now, but it isn't necessarily the primary like containers first within an enterprise. You see that in cloud native, right? Born in the cloud companies sort of immediately moved into that. But serverless still feels to a lot of the big enterprises migrating to cloud, that's like a holy grail, right? They're reaching towards that. I don't know how much they're thinking about what's next. So I wanted to say that before you suggest what might be next, Erik, right? So that they, kind of helps people frame it differently.
So I hadn't thought about this before you brought up that point, Mallory, but it kind of does reinforce in my own mind my thinking earlier, which is if you think about a stodgy enterprise who isn't even leaned into sort of a cloud native architecture, but they have a well-defined application. That well-defined application is much more portable into a container that you can then move into ECS, Kubernetes, et cetera, as opposed to trying to think about like, oh, well, how do I decompose that into 1,000 different serverless functions? And so if you can have the best of both worlds where you have a code base that is put into a container and can act in a serverless way by virtue of being in that container, then you sort of skip that, what we had previously thought of as the transition to serverless. And you just say like, no, we're just going to containerize this thing, but we can still treat it as if it was a serverless application, but it's the way we package our, I'm just imagining like a WAR file or EJB file, like really old packaging technologies that people have a lot invested in, they're not going to change. Those can still be containerized. And now you can treat them as serverless if you want to, but you just skip the step of like trying to plan for a serverless migration because you don't need to do that anymore. And in a lot of ways, I think what we saw over the last, what is Lambda, like 6 years old now? I think it's older than we tend to think of. Like AWS announced it, not 6, but maybe like 4 years old. We always thought of like, oh, you've got to migrate to serverless or you start from a point of serverless. And I'm not sure that's the case anymore. If you start from a place of we have container functions or container applications, but it's the same deployment model, now you don't have to reason about 2 deployment models. And that's potentially a really good step for a more slow moving enterprise to containerizing it is not hard for them to reason about. At one point, those applications ran on bare metal and they virtualized them, right? So they begrudgingly caught up to that standard. Then they begrudgingly said, okay, we've got to run some of these things in the cloud. But if you can engage them and say, put it in a container and you can treat it as serverless in certain areas, now they don't really have to think about a re-architecture again per se.
I quite like that. And it gives us the nice benefit of, well, in theory, the scalability, although I bet some apps won't play that well with that, but at least the resilience. And then that ability, Mallory, to maybe benefit from some of the Spot capability by having the container middleware manage a lot of that mess for us without us having to get our hands too dirty, I hope.
Yeah, and not just chasing the next thing, right? Like doing it, like you said, Erik, if it's a clear application, like really saying, well, does this need to be serverless? If so, how? Right? We don't need to break this into 1,000 microservices if it's serving its purpose, right? Like just being intentional.
I think ultimately businesses use technology to further their business goals. And to borrow some of our thinking from the Cloudability days, if you containerize an application but use it in a serverless way, you fastly converge on unit economics of what it cost you to do that, right? You're not running a fleet of application servers that sit idle for 99% of the time. They respond to a request, and now you can start to get closer to what did this business operation that one of my customers performed cost me on a unit economic perspective. Containerized functions allow you to do that without refactoring something into a Lambda application. That's another way to sort of look at this in my mind. Bigger, really long-term arc of where this all ends up is whether it's a serverless function and a small chunk of code or a containerized application. I think we'll start to see effectively static analysis of code paths through those units of code, if you will. Serverless function, big application invoked serverlessly, if you will, with certain invocation paths where effectively you can have this meta level of optimization for cost purposes. So for example, certain serverless functions are going to be more CPU intensive, and you can do static analysis of the code, or you can actually do sort of dynamic runtime introspection of that and see, okay, well, this is a CPU heavy function, or this is a memory heavy function. This is a specific instruction set heavy function. And I think over time, we as developers will write pieces of code, we will deploy them, and the cloud service providers will actually do architectural level optimization of where they're deployed in real time for us. So for example, there's going to be certain functions that are going to be way more cost effective, or like certain serverless functions, let's just limit it to that for now, that are going to be way more cost effective to operate on ARM infrastructure versus Intel infrastructure. And some are going to be more memory intensive, some are going to be more CPU intensive, some are more network intensive. Over time, I don't think we will think about much of the underlying architecture anymore, which is hard for me to even say as somebody who's always been usually been a lower level systems person. Like certain instruction sets will optimize well for certain chunks of code, whether it's serverless or whether it's a containerized application with a certain call graph through that. And the cloud service providers will just start to cost optimize that for us, and we'll pay for it, but we won't know whether it ran on an ARM CPU or a specialized piece of hardware, whether it ran out on the edge or whether it ran in the data center. It'll be business value things that we need to have done. And the cloud service providers will optimize it across all the major sort of performance dimensions for us, which we normally think of as CPU, RAM, disk IO, network IO, sometimes GPU, depending on the workload, things along those lines.
Well, we've only got a few minutes left, folks. So let's do one final topic, and that is, AWS reInvent wrapped up late last year. And what was everyone's most memorable announcement? Alex, why don't you go first? We've sort of been touching on it during this conversation.
Oh yeah. So Eric, you mentioned it earlier, the millisecond level billing for AWS Lambda functions. Now, I think this is it's quite interesting that we can get to this level of precision now. I've already seen some really interesting conversations with practitioners in the FinOps Foundation talking about how this opens up potentially new use cases that weren't necessarily viable before. So I'm super interested to see how people leverage this as we go into 2021.
Quick story on that. I did see a cloud native, their mobile app company, their Lambda costs through no changes of infrastructure post-announcement dropped 60%. Now, just because it was measured in milliseconds, it's fascinating, right? Now, what's interesting is that when we say 60%, it went from, I don't know, $2 a day to 80 cents a day, which is, 60%. But nevertheless, it's interesting how much the cloud providers are competing at the fringe for the next, the latest, the greatest, right? And so this has a clear benefit to heavy users of Lambda. But at the same time, not everyone is at that stage, number one. And number two, it also has implications if you have savings plans, right? Because those compute savings plans, I should say, apply to Lambda functions, right? And so there's a lot of interplay with Lambda. It's a great announcement, but I think there's more complexity than we initially recognize.
In terms of announcements, I still have a really infrastructure slant to how I look at things. So the millisecond billing for sure stood out to me, but also the emergence of GP3, which I think is going to change how you reason about, your storage volumes and how, do you convert, do you take the risk of performance impacts or not? Like it's where it should be. And I think one thing that people generally don't give AWS in particular enough credit for, which is their innovation in the storage area. So they've just done so many amazing things with EBS and our ability to snapshot them and performance and think about that, especially compared to where it was. The other things I would highlight are the management systems that they're providing over the top, which I think are super cool. And your AWS products are normally very compartmentalized, and they're starting to actually give us an overlay over the top of those, which I think is good and needed and overdue.
Having said that, let me still tell you my favorite announcement. Nevertheless,
Go on, Mallory.
The AWS EKS Anywhere, where you can use AWS's EKS technology in an on-prem environment. I think this is a really sharp move on AWS's part. It recognizes how many enterprises are migrating from their data centers from on-prem into cloud. We've talked so much in this conversation, but also, in our own circles about the portability of a containerized workload. And we talk about it preventing vendor lock-in, but AWS has done one better and said, actually, we're going to make it so much easier to pick something up out of your data center and put it into a cloud infrastructure place using the same kind of supported infrastructure. I think it's very clever. It really speaks to a lot of the enterprises that are migrating, and I think they're going to have a lot of success with it. AWS, they're aware that their customers are doing migrations out of their data centers and into cloud. And it's not the first time that we've seen a product from AWS that facilitates that, right? So Snowball is the most obvious example, right? Where you're trying to get all that data into cloud. This feels like an extension of that, but recognizing that we're seeing more and more containerized workloads. So were they forced? Probably, but also, AWS is incredibly customer focused, right? It's one of their core principles. And so
the benefit of them again, to be honest with you. Yeah. Thank you very much, Erik. And thank you, Mallory. This has been a really fun little kind of look down memory lane from last year and a little bit of a gaze into the future. But before we go, we actually want now to kind of get your questions and your feedback on what do you thought about the topics we covered today. If there are topics you'd like to see us cover or questions you're wrestling with your organization or with your move to the public cloud, and what should we be doing about that? How do we do this in a certain way? Please get in touch. You'll be able to reach us at cloudbusters@apptio.com. We're also working on a Cloudbusters LinkedIn group page, which by the time this is broadcast should be available. So please feel free to get in touch with us on that as well. And we look forward to having your questions on here and getting our guests to help share their expertise on their guidance on how we would address them. But before we go, I know that lockdown and all of us being in these lovely kind of remote home offices, or the blank void I'm basically in right now, to use a John Oliverism, has kind of left us with some kind of interesting behaviors. And Mallory, I know you've had a personal favorite, which I've heard of as your amazing hat collection. So I was wondering if you could share with a hat this week, so we can see one of these samples of what your lockdown activities been.
Yes, indeed. Thank you for asking. I love hats, and it's a great way to entertain myself when I'm stuck at home in my home office instead of working with my colleagues. So today's hat, Alex, it's the inaugural video of Cloudbusters, where we discuss hot cloud topics and issues, where we may in future bust some myths about cloud. So that seems like we are kind of like cloud detectives in a way, a little bit. So I chose the closest hat I have to a detective's hat, which is my fedora.
Oh, beautiful. Very super slippery.
Thank you. So everyone, thank you so much for joining us on our Cloudbusters video. Erik, thank you so much for joining us and sharing your story. And we will see you all in our next episode.